by z dz. 1 by z dz is. We have options here. First option 0. Second option minus 1 by 6. Third option, I'm writing options here for my convenience. First option 0. Second option minus 1 by 6. Third option minus pi I by 3. And the fourth option is pi I. These are the four options we have. Okay. Just we have to uh, uh, calculate the integral value. So we go for residues. Okay. First, I'm taking the function f of z is equal to z square into sine 1 by z, and expand the sine z. Okay. As we know that sin x expansion is like, we know the expansion of sine is an odd function. So sin x is equal to x minus x cubed by 3 factorial. We will see discuss in the Taylor series, Maclaurin series also. First, I'm giving the expansion of sin z, just a formula that is, you can write sine is an odd function. That's why it takes all odd powers. So sin z is equal to z minus z cubed by 3 factorial plus z power 5 by 5 factorial minus z power 7 by 7 factorial plus and so on. This is the expansion of sin z. But we need to expand sin 1 by z. So just replace z by 1 by z here. So we get z square into z. Z means 1 by z minus 1 by z whole cube by 3 factorial plus 1 by z whole to the power of 5 by 5 factorial plus minus plus or minus alternatively we take 1 by z whole to the power of 7 by 7 factorial plus and so. These are the this is the expansion of the sine 1 by z. So simplify it. Z square into, here we can write 1 by z minus here 1 by 6. Or we can write the 3 factorial. Simply I'm writing 3 factorial into z cube plus 1 by 5 factorial into z power 5 minus 1 by 7 factorial into z power 7. Next term plus and so on. Okay. And multiply the term with z square. So we get first term z minus second term is 1 by 3 factorial z plus third term is 1 by 5 factorial z power 4 minus and so on. Okay. Now, but we have to calculate the residue where xi is the simple closed curve, means for residues we have to take the singularities. Singularities means the denominator, that means 1 by z. That means z is equal to 0. At this point, we have to calculate. This is the singular point. This is singular point. At this point, we have to calculate the residue. Therefore, residue of the function f of z at z is equal to 0 is equal to, by basic definition, yesterday we discussed, or in the previous class also we discussed the basic definition of residue. That is the coefficient of z minus 0 whole power minus 1. That is nothing but z power minus 1 coefficient, that is minus 1 by 3 factorial. That is equal to minus 1 by 6. This is the residue only, but we have to calculate the integral value. So integral over xi, z square into sine 1 by z. This is f of z dz is equal to, by definition of residue, we have to write 2 pi I into residue, that is minus 1 by 6, that is equal to minus pi I by 3. Okay. So this is the right option. Third option is the right option. Option C. Okay. Option C is the right option. Okay. Now I'm taking another problem. Yeah, it's a DL problem, very simple, direct ability it is. If Z is equal to 0 and Z is equal to 3 lies inside a simple closed curve. A simple closed curve. Simple closed curve C. Then integral over C dz divided by z into z minus 3 is equal to. Okay, we have options. First option is I think it is 0. Second option, example it's going to be 2 pi I by 3, and third option is minus 2 pi I by 3, and also fourth option is 2 pi. Okay, just we have to calculate, no need to calculate the singularities. We are given the singularities, those singularities are inside the simple closed curve. So we have to find the residue at z equal to 0 and z equal to 3. Clearly we can observe here z equal to 0 and z is equal to 3 are simple poles. These two are simple poles. When they are simple poles, we can calculate the residue as very simple. That is, we have to calculate the residue and the function f of z. So I'm taking first, we can take f of z. Okay, I'm writing directly residue of f of z, that is equal to limit z tends to 0, z into f of z. F of z is 1 by z into z minus 3. Here z will be cancelled, that is equal to minus 1 by 3. Okay. First, the residue at the point z equal to 0. Similarly, we can calculate the residue at z is equal to 3. So that is equal to limit z tends to 3. It is z minus 3. This simple pole, that's why we are writing that like this. Z into z minus 3. Here z minus 3 will be cancelled. This is equal to 1 by 3. Okay. So we have to add them by Cauchy residue theorem. So integral over C f of z dz is equal to 2 pi I into sum of residues. Sum of residues. Sum of residues means here I am mentioned here by Cauchy residue theorem. Cauchy residue theorem. Okay. While using this theorem, we can write 2 pi I sum of residues. First one is minus 1 by 3, and the second one is 1 by 3. This will be 0. So first option is the okay. Now, yeah, I'm taking another problem. Is the function f of z. We're taking the function. Yeah, yes. The function f of z is equal to the function f of z is equal to z square minus 2z plus 3 divided by z minus 2 as. Okay, we have options. So I'm writing here. First option, pole of order 2 at z is equal to 2. Pole of order 2 at z is equal to 2. Okay. Second option, essential singularity at z is equal to 2. Essential singularity at z is equal to 2. And the third option, pole of order 1 at z is equal to pole of order 1 at z is equal to 2. And the fourth option, no singularity at all. No singularity is. So we have to see the function of z for singularities. We have to take the denominator singularities. The denominator z minus 2 is equal to 0. So z is equal to 0. Z minus 2 0 as 1 times. That means z is equal to 2 is simple pole. Simple pole. Simple pole means it is a pole of order. Therefore, z is equal to 2 is a pole of order 1. Okay, it is a pole of order 1. So we see the options here. First, third option. See the first option, pole of order 2 at z is equal to 2 is wrong. Essential singularity, pole of order 1 at z is equal. So third option is the right option. Okay. Now we can take another problem. Let us seize the set problem taking. Letter C be the circle. Modulus of z is equal to 3. Modulus of z is equal to 3. Then the value of the integral, and the value of the integral over c z cube minus 3 divided by z minus 2 whole to the power of 3 is. We have options here. First option pi I, second option 12 pi I, third option 2 pi I, fourth option it will be 0. Okay, so we can observe here clearly when the denominator is 0, z minus 2 equal to 0. That means z is equal to 2 is a pole of order m is equal to 3. Okay, clearly we can observe this. It is a pole of order 3. So we have to calculate the residue, then integral value. So, and z is equal to 2. Is it inside or outside? You know that this is a circle of radius 3 units, 1, 2, 3. So z is equal to 2 is inside, no problem. So we have to calculate the residue of the function. Therefore, residue of f of z at z is equal to 2. Okay, f of z means here z cube minus 3 by z minus 2 whole cube. That is equal to 1 by 3 minus 1 factorial. This first I am writing the limit z tends to 2, 1 by 3 minus 1 factorial into d power 3 minus 1, that is d square by dz square of z minus 2 whole cube into and f of z, that is z cube minus 3 divided by z minus 2 whole cube. Okay, we can cancel z minus 2 whole cube as z minus 2 whole cube. So this is nothing but 1 by 2 factorial is 2, limit z tends to 2. Here 2 times differentiation d square by dz square of z cube minus 3. So this is equal to 1 by 2 limit z tends to 2. First time differentiation is 3z square. Okay, again differentiate this with respect to z. That means limit z tends to 2. That is 6z. So 6z means apply z equal to 2. That is 1 by 2, 6 into 2 is nothing but 6. So 6 means you have to, this is the residue, just a residue. but we have to calculate the integral value. So 6 in 2 pi I into 6, that is nothing but 12 pi. Direct kuda raskochu ledante we can use the definition of residual. F of z dz is equal to 2 pi I into 2 pi I into 6, that is equal to 12 pi I. This is the integral value of the given function. Okay. Now I'm taking another problem. This is a DL question. The value of the complex integral, the value of the this one. Yeah, the DL question. The value of the complex integral, complex integral over C z cube into e to the power of 1 by z square dz, where C is modulus of z is equal to 1. Okay. First option is 0. Second option is 2 pi I. Third option is pi I. And fourth option is pi I by 2. These are the four options. First, we have to take a function f of z is equal to z cube into. First, we can see the singularities. Okay. Until first expand this one e to the power of 1 by z. That is equal to z cube into expansion of e to the power of 1 by z. That is 1 plus 1 by z by 1 factorial plus 1 by z whole square by 2 factorial plus 1 by z whole to the power of, and so on. And then just okay. So this is equal to, we can write z cube here 1 plus 1 by z plus 1 by 2 factorial into z square. Next term is 1 by 3 factorial into z cube. Next term is 1 by 4 factorial into z power 4 plus and 4 factorial. This is 4 factorial. So this is equal to plus and so on. Okay. So multiply with the z cube. When we multiply with the z cube, we get a z cube first term, z square second term, 1 by z by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial z plus and so. So we have to write the residue of the function at z is equal to 0, because 1 by z is not defined at z is equal to 0, so that it is a singularity. So for this singularity, at this singularity, we have to calculate the residue. That means residue of f of z at z is equal to 0 is equal to the definition, basic definition is coefficient of z power minus 1. Z power minus 1 by exponential of z square. Sorry. I'm sorry. Is 1 by z square. So 1 by z square whole square. So we have 1 by z square here 1 by z power 4. It is 1 by z power 6. It is no limit. Okay. So here first term is z cube, second term is z, third term is 1 by 2 factorial into z, 2z, and here 1 by 3 factorial, that is z cube, 1 by 6 into z cube. Okay, no need to take these terms. So the residue of f of z is z power minus 1 coefficient, that is 1 by 2. Whenever it is 1 by 2, so 2 pi I into 1 by 2. అలా మీరు డైరెక్ట్ రఫ్ గా క్యాలిక్యులేట్ చేసుకుంటే అప్పుడు pi I is the answer. అంటే ఇంటిగ్రల్ ఓవర్ c f of z dz is equal to 2 pi I into residue, that is 2, that is equal to pi I. So pi I is the, okay, so what is pi I? Third option is the right option. Okay. Now we can take another problem. If for f of z is a jail question. Simple, but simple. I think it is completed in the last class. Essential singularity problem మనం చేసాం. Now I'm taking another problem. This also. Okay. Just 1 by it is not the jail problem. It's a problem. 1 by 2 pi I integral over c 3 e to the power of 2z divided by z minus 1 whole to the power of 4 into dz is equal. We have options here. First option 4e square. Second option 0. Third option 2 e to the power of minus 2. And the fourth option 8 by I 3 e square. It is with two options. You can observe here. Sorry. We can observe here z is equal to, which means over c 3 e power 2 z by z minus 1 to the power of dz is equal. Okay. First, we have to see the singularities. Clearly, z is equal to 1 is a pole of order m is equal to 4. So we have to calculate the residue at this point. It means residue of the function f of z. F of z means here 3 e power 2z by z minus 1 whole to the power of 4. Okay. So at z is equal to 1. That is equal to limit z tends to 1 by 4 minus 1 factorial into d cube by dz cube. Z minus 1 whole to the power of 4 into 3 e to the power of 2z divided by z minus 1 whole to the power of 4. Okay. So 3 it is nothing but 3 factorial is 6. So this is 2. We can cancel this. So 1 by 2 limit z tends to 1 d square by dz square. One time differentiation is 2 e power 2c. So 2 will be cancelled. Again differentiate 2 times. That is equal to limit z tends to 1 d by dz of 2 e power 2z. 2 e power 2z. So this is equal to limit z tends to 1 4 e to the power of 2z. Apply z is equal to 4 e. This is the calculation of residue only, but we have to calculate the integral value. Therefore, by definition of residue, f of z dz is equal to 2 pi I into residue, that is 4 e power 2. Okay. So, therefore, we have to write the integral 1 by 2 pi integral over c f of z dz is equal to 4 into e square. This is the right. So first option is the right option, and here fourth option is 8 pi I by 3 e square. Okay. Now I'm taking another problem. The coefficient of a function is option 1. I'm taking the set question. The function f of z is equal to the function f of z is equal to e to the power of z minus 2 divided by z minus 2 as. Yeah. As we have options here. First option, of course, it is a OU PhD entrance question. Okay. But it is a state set question of other state, Maharashtra. First option 1 is a pole at z is equal to pole at z is equal to 2. Second option, a removable singularity. Removable singularity at z is equal to a removable singularity at z is equal to 2. Third option, an essential singularity at z is equal to 2. And fourth option is a regular pointer at z is equal to a regular point at z is equal to 2. Okay. So first we have to expand the function, that is 1 by z minus 2 into e power z expansion, z minus 2 plus z minus 2 whole square. Sorry, one is there. I'm sorry. 1 plus first term is 1 plus z minus 2. Second term z minus 2 whole square by 2 factorial plus z minus 2 whole cube by 3 factorial plus and so on. Okay. So multiply with the z is equal to z minus 2. 1 by z minus 2 will get to 1 by z minus 2 plus second term 1 here z minus 2 by 2 factorial. Here z minus 2 whole square by 3 factorial plus and so on. Okay. So clearly we can observe from here to here. This is the completely analytic part. When z is equal to 2, the function is, so it is analytic part. Analytic part means z is equal to 2 is not singular, is analytic part. It is a principal part, is principal part, and the function is not analytic at z is equal to 2 at once. That means z is equal to 2 is a simple pole, is a simple pole. So we have to observe the conditions. Okay. First I am taking first option, a pole at z is equal to 2. A removable singularity, it is not available. Essential singularity. Okay. Principal part has only finite number of terms, regular points. So pole, simply a pole at z is equal to 2. Okay. But it is a simple pole. We can observe it is clearly essential. Okay. Now, we can take another problem. The function f of z is equal to sin z divided by z minus pi whole square as the pole of order, is. So pole of order is. First write the options. First option 1, second option 2, third option 3, fourth option 4. 1, 2. So clearly we can observe the function for singularities. Clearly we can observe z minus pi whole square equal to 0 means z is equal to pi is a pole of order 2. Is a pole of order 2. Okay, మనం అడిగింది ఏంటి, pole of order is అన్నాడు, order 2 direct we can. Okay, next take another problem. Z is equal to the function
pole of order 1, sir.
Pole of order, it is a pole of order 2 అండి. 2 times 0 కదా. Okay, z is equal to pi 2 times అవుతుందండి.
sin z ని sin pi minus z
రాసుకోండి. sin pi minus z రాసుకొని ఎక్స్పాండ్ చేయండి. ఇలా చేయండి, వస్తుందా చూద్దాం. ఓకే, ట్రై చేద్దామండి. f of z is equal to sin z by z minus pi whole square sin pi minus z, sin 180 minus theta is sin theta, divided by, this can be written as pi minus z whole square. So sin 1 by pi minus z whole square, expand చేయండి. Pi minus z minus pi minus z whole cube by 3 factorial plus pi minus z whole to the power of 5 by 5 factorial plus and so on. So first we can write 1 by pi minus z. Okay, pi minus z whole square by 3 factorial plus 5 minus z whole to the power of 4 by 5 factorial minus and so on. Okay. Yes, this is the analytic part. ఇక్కడ sign consider చేయకుండా just denominator. Okay. So it is a principal part. It is principal part. Principal part, that means z is equal to pi only one time. One time means z is equal to pi is a simple pole. Is a simple pole. Simple pole means pole of order. Pole of order 1. Pole of order is equal to 1. So, sorry, first option is the right option. Okay. Only మనం denominator consider చేయకుండా ఓకే ఓకే ఇలాంటి ప్రాబ్లం ఒకటి డిఎల్ లో అడిగాడండి 1 సెకండ్ yeah okay the function f of z the function you're taking a real question the function f of z is equal to sine of z minus 1 divided by z minus 1 as options we have as removable singularity. Removable singularity. Singularity. At we have options. First option z equal to 0. Second option z is equal to 1. Third option z is equal to infinity. Fourth option z not is equal to 1. These are the 4 options. Removable singularity means there is no principal part. There is no principal part. Okay. So first of all, we have to expand the function sine z minus 1 by z minus 1. That is f of z is equal to 1 upon z minus 1 of expansion of z minus sine z minus 1. That is z minus 1 minus sine of z minus 1. So this is equal to, we can write z minus 1. It is z minus 1 minus z minus 1 whole cube by 3 factorial plus z minus 1 whole to the power of 5 by 5 factorial minus and so. Okay. So apply, multiply with 1 by z minus 1. We'll get the first term is 1. Second term z minus 1 whole square by 3 factorial plus z minus 1 whole to the power 4 by 5 factorial minus and so. Okay. Here we can observe there is no principal part. This is completely analytic part only. Analytic part. Analytic part. And as no principal part. As no principal part means principal part at z is equal to 1. So therefore z is equal to 1 is removable singularity. Removable singularity of the function. Okay. If it has infinite number of terms and essential singularity, it has no principal part means removable singularity. Okay. Now we can take another problem. The problem. Actually, we did this for the receipt of z into e to the power of z divided by z minus 1 whole cube at z is equal to 1 is. Okay. We have first option e by 2, second option 3e by 2, third option 3 by 2e, and the fourth option is minus 3 by e, minus 3 by 2e. Okay. So first we can see, you can observe when we take f of z is equal to the function as is z e power z by z minus 1 whole cube. Clearly, z is equal to 1, z is equal to 1 is a pole of order m is equal to 3. Okay. So we have to calculate the residue at this point. The order. So residue of the function f of z at z is equal to 1 is equal to limit z tends to 1 by 3 minus 1 factorial. That is 3 minus 1 factorial. Derivative, second derivative, that is d square by dz square of z minus 1 whole cube into z into e to the power of z divided by z minus 1 whole cube, f of z function. Okay. Z minus 1 will be, z minus 1 whole cube will be cancelled. So 1 by 2 factor is 2. Limit z tends to 1 d square by dz square of z e power z. Okay. So this is equal to 1 by 2 a differentiation of z e power z by using UV formula z e power z plus e power z. Again differentiate, we get limit z tends to 1. 1 by 2 limit z tends to 1. Again differentiate z e power z plus e power z. Okay, ఇక్కడ వరకు అయిపోయిందండి. Then e power z derivative e power z. So apply z is equal to apply z is equal to 1 here, 1 by 2, it is e power 1, e power 1, e power 1, 3 e power 3e. Okay, that is nothing but 3 by 2 e. 3 by 2 e. 3 by 2 e. Okay, second option is the okay. Now I'm taking another problem. The residue of the function DL question. The residue of z into cos 1 by z at z equal to 0 is, of course it is a set question also. We have options here. Option 1, 1 by 2. Option 2, minus 1 by 2. Option 3, 1. Option 4 is 0. So first of all, we have to take the function f of z, that is z cos 1 by z. That is equal to, cos is an even function. So the expansion of this is 1 minus 1 by z whole square by 2 factorial plus 1 by z whole power 4 by 4 factorial minus and so. Okay. So this is equal to z of 1 minus 1 by 2 z square, first term, 1 by 24. Z power 4 minus and so on. So this is equal to Z minus 1 by 2Z plus 1 by 24 Z cube minus and so on. Okay. So residue of this function f of Z is equal to, at Z is equal to 0, Z equal to 0 is the singularity. That is equal to, simply we can write the coefficient of Z power minus 1. That is equal to minus 1 by 2. Okay. So second option is the right option. Okay. And you can take another problem. Is also value of the integral, complex integral is complex integral. The value of the complex integral over C Z cube into, I think it is complete. Yeah, it's completed. Sorry. Okay, in option question rations. Z cube into e to the power of 1 by Z square dz, where
Sir, repeated question, sir, this question.
okay, Z equal to what? Yes, the answer is I think pi I. Ane kada?
Yes, sir.
Now I'm taking another problem from DL. Is also DL. Let f of Z equal to a plus bz plus cz square and integral over C f of Z by dz. F of Z by Z into dz is equal to 4 pi I. Comma, integral over C f of Z by Z square into dz is equal to 6 pi I integral and integral over C f of Z by Z cube into dz is equal to 8 pi I. 8 pi I. Where C is modulus of Z is equal to 1. Then the values of A comma B comma C, A B C are respectively are we have options here. Options which are first option 1 comma ఇక్కడ and ఉంటుందండి C, ABC, AB and C respectively are 1 comma 2 and 1. Second option 2 comma 3 and 4. Third option 3 comma 2 and 3. And fourth option 1 comma 1 and 1. Okay, respectively. What's the music picture? First, we have to see the integral value. Before going to see the integral value, we can recall the Cauchy, second option. Okay, please check. Yeah. First, we recall the definition of Cauchy general integral formula. Cauchy general integral formula. From this formula, we have integral over C or 1 by 2 pi I, 1 by 2 pi I, integral over C of Z divided by Z minus Z naught whole to the power of N plus 1 is equal to nth derivative of Z naught. Okay. So we can write the integral value only. That is integral over C, here dz dvc, f of Z divided by Z minus Z naught. Okay, here by n factor this is. Okay, Z minus Z naught whole to the power of n plus. That is equal to 2 pi I f nth derivative at Z naught divided by n factor. This is the, we are rearranging the definition of Cauchy general integral part. Okay. So take this L, we will calculate the function. Okay. But you have to see, C is the circuit for every function. If you take first integral, second integral, and third integral, in all cases, here the Z is equal to 0 is the singularity. Here Z is equal to 0 singularity. Here also Z is equal to 0 singularity. Okay. But here a simple pole, it is a pole of order 2, it is a pole of order 3. And pole of pole to compare this, and it is take time. Okay. So we can use the Cauchy integral form. Okay. So we have to take clearly Z is equal to 0. That means Z naught is, it is Z naught. Okay. Is a pole, is a pole. Either it is simple pole or pole of order 1 or pole of order 2, but pole of order 2 or pole of order 3. First, for at this point, we have to calculate the functional value, but we are given f of Z is equal to a plus bz plus cz square. So f of Z naught ante 0 ante. Okay. Bracket lo raastanu. Z naught means 0. At this point, we have to calculate the functional value, that is a. Okay, a plus 0 plus 0. Okay. Now, first derivative, f dash of Z, that is equal to b plus 2cz. This implies f dash of Z naught is equal to b only. Dash of Z naught is equal to b. And the second derivative of the function f of Z is equal to 2c. Okay. So at this point, at this for this derivative, we have to calculate the functional value at Z naught. That is 2c. Okay, it is constant 2c. Okay, all the values are first, second derivatives find out chesam. Manaku second derivative ఇక్కడ థర్డ్ డెరివేటివ్ తీసుకోవట్లేదంటే z పవర్ 3 ఉంది, 3 కెన్ బి రిటన్ యాస్ 2 ప్లస్ 1 అండి, మాక్సిమం ఇదే కాబట్టి సెకండ్ 2 అనేది డెరివేటివ్ రిప్రజెంట్ చేస్తుంది కాబట్టి నేను సెకండ్ డెరివేటివ్ దగ్గర క్లోజ్ చేశాను. నెక్స్ట్ మనకి ఇచ్చిన కండిషన్స్ తీసుకుందాం. ఫస్ట్ కండిషన్ ఏంటంటే ఇంటిగ్రల్ ఓవర్ సి, నా integral over C f of Z by Z dz. Z naught is equal to 0 in the every case. So this can be represented as integral over C f of Z divided by Z minus Z naught into dz into dz. So by here we have to observe Z naught is equal to 0 Z naught is equal to 0. N is equal to, this is 0 plus 1 and N is equal to 0. What is the formula we have here? 2 pi I nth derivative with Z naught divided by n factor. This is the formula. So apply in this formula. We get 2 pi I into nth derivative. N equal to 0 means no derivative. F of Z naught. F of Z naught divided by 0 factorial. That is equal to 2 pi I into, at this point, f of Z naught value is 1, sorry, A. So this is A. 0 factorial is 0. So this is equal to, actually, we are given integral over C f of Z dz by f of Z by Z into dz is equal to 4 pi I అని ఇచ్చాడండి. అంటే ఇక్కడ దీని వాల్యూ ఏమవుతుంది? This implies 4 pi I is equal to 2 pi I A. This value is, we are given already. Okay. Pi I 2 cancel. So A is equal to 2. Okay. A is equal to 2 వచ్చేసిన తర్వాత మనకు ఏబిసి ఇన్ ఆర్డర్ అన్నాడండి, రెస్పెక్టివ్లీ అన్నాడు. ఫస్ట్ ఆప్షన్ లో ఫస్ట్ది ఏ అండి. ఏ అంటే 2 ఉండాలి. 2 ఎక్కడ ఉంది? ఇక్కడ ఉంది. మళ్ళీ ఫస్ట్ దాంట్లో ఎక్కడ కూడా లేదండి, కాబట్టి నో నీడ్ టు క్యాలిక్యులేట్ రిమైనింగ్. జస్ట్ 2 ఆప్షన్, సెకండ్ ఆప్షన్, రైట్ ఆప్షన్ పెట్టచ్చు. ఓకే, ఇక్కడే మనం డైరెక్ట్ పెట్టచ్చు. ఒకవేళ 2 అనేది థర్డ్ లో కానీ ఫస్ట్ 2 ఉంటే అప్పుడు మళ్ళీ 10 చెక్ చేసుకోవాలి. నెక్స్ట్ ఏంటనేది చెక్ చేసుకోవాలి. ఓకే, సరే, మనము ఇక్కడ మనం పెట్టేయచ్చు. ప్రాబ్లం అయిపోయిందండి, బట్ వీ కెన్ చెక్ మనం చేసింది కరెక్టా లేదా, వ్యాలిడిటీ చెక్ చేసుకుందాం. ఓకే, 1 సెకండ్ ప్లీజ్ స్టే అండి. Yes. So we have to verify the remaining options also. Okay. So I'm taking the second bit, that is integral over C. We are given integral over C f of Z divided by Z square into dz. That can be written as integral over C f of Z divided by Z minus Z naught whole to the power of 1 plus 1. 1 plus 1. Okay. So 1 plus 1 means you have to observe here Z naught is equal to 0, N is equal to 1. N is equal to 1. So the formula is 2 pi I. What is it? This is equal to 2 pi I into f nth derivative. If n equal to your 1, 1 means first derivative. F dash, sorry. Into f first derivative, n equal to 1 here. N is equal to 1, Z naught is equal to 0. So write 2 pi I into, here N is equal to 1, Z naught is equal to 0. So Z is equal to 0. Okay. So it is 2 pi I f nth derivative, that is first derivative of Z naught divided by 1 factor. So this is equal to 2 pi I into, we are given that F dash of Z naught. F dash of Z naught is B. So it is B. And we are given the integral over C f of Z by Z square into dz value. That is 6 pi I. So 6 pi I is equal to 2 pi I. Pi I will be cancelled to this one. So B is equal to 3. Okay. Now we go for third one is integral over C f of Z divided by Z cube into dz, that is equal to integral over C f of Z divided by, we can write it as Z minus Z naught all to the power of 2 plus 1. Okay. Here n is equal to 2 and Z naught is equal to 0. Okay. So this is equal into dz. This is equal to 2 pi I into f second derivative. F nth derivative at Z naught means f second derivative at Z naught divided by 2 factorial. That is equal to 2 pi I. Second derivative is we get at Z naught is 2c. So this is 2c divided by 2 factorial is 2. That is equal to 2 pi I c. And we have the value integral over c f of z by z cube into dz value we are given, that is 8 pi I. Pi I will be cancelled. 2 4s are. So c is equal to 4. Okay. మనం సెకండ్ ఆప్షన్ తీసుకున్నాం. సెకండ్ ఆప్షన్ చూస్ చేసుకున్నాం. ఇక్కడ 2 3 a ఈక్వల్ టు 2 b ఈక్వల్ టు 3 అండ్ c ఈక్వల్ టు 4 వచ్చేసాయి. ఓకే. కాబట్టి ఇక్కడ ఒకవేళ మనకు ఇందులో ఫస్ట్ థర్డ్ ఫోర్త్ లో ఎక్కడైనా ఫస్ట్ 2 ఉందనుకోండి, ఇంకో ఆప్షన్ చెక్ చేయాలి. లేదు అంటే ఇక్కడ ఫస్ట్ a ఈక్వల్ టు 2 వచ్చేసింది కాబట్టి ఇక్కడే మనం స్టాప్ చేస్తే లోపం. ఓకేనా. నౌ I'm taking another problem. We'll discuss tomorrow with this. I conclude. Okay, if you have question, you can ask. Anyone, do you have question? You can ask.